Okay, so the notes for 2.4 are called rates of change in tangent lines. We're going to start by first looking at the average rate of change. The average rate of change is equal to delta y over delta x. This should look very familiar from Algebra 1 because this is the same formula for finding the slope. Graphically, the average rate of change is equal to the slope of the secant line. The secant line is a line connecting 2 points on a graph. So in our case, this red line is our secant line. It connects the points P and Q on our blue graph. So to find the average rate of change, we're going to find the change in x and the change in y and divide the two just as we would if we were looking at the slope of a line. So our example is find the average rate of change of f of x equals x cubed minus x plus 20 over the interval 1 to 4. So to do this, we're going to look at both ends of our interval. We're going to look at the lower end, which is when x is 1, and the higher end, which is when x is 4. So we're going to pretend, based on our example, that point P represents our lower end. So for us, P is when x is equal to 1. So we'll put in 1 into our equation. So we have 1 cubed minus 1 plus 20, which is 1 minus 1 plus 20, which gives us 20. Now our second endpoint is going to represent Q, and that is when x is equal to 4. So again, we'll substitute 4 into our equation. So we have 4 cubed minus 4 plus 20, which gives us 64 minus 4, which is 60, plus 20, which is 80. So what we want to do now is we're going to find the average rate of change. So we want our delta y, which is our y values from our highest endpoint minus our lowest endpoint, and delta x, which are our x values from our highest endpoint minus our lowest endpoint. So f of 4 we got was 20, and f of 1, sorry about that, f of 4 is actually 80 minus f of 1, which is 20, all over 4 minus 1, which is 3. 80 minus 20 is 60 over 3. So our average rate of change is 20. Okay, so when we're finding average rate of change, this is really important, the word average. Okay, when we're finding our average rate of change, we are looking for the slope between 2 points on our curve. So we're looking for the slope between 2 points on our curve when we're looking for the average rate of change. The next page talks about instantaneous rate of change, which is just a little bit more different. Page 2 of the notes deals with instantaneous rate of change, which occurs at only one point. So our instantaneous rate of change happens at a point. And the way that we find the instantaneous rate of change is we first look at the average rate of change, and find the limit as delta x approaches 0. So graphically, the average rate of change was the slope of the secant line, whereas the instantaneous rate of change is the slope of the tangent line. The tangent line is the line that intersects our curve at exactly 1 point. So if you look at the graph below, this green line is our tangent line, is the line that intersects our graph at exactly 1 point. For example, we want to find the instantaneous rate of change of f of x equaling x cubed minus x plus 20 when x equals 2. So in order to find our average rate of change first, we need some sort of interval. Okay, average rate of change uses interval. So in our case, we're only given a point. So we know that one end of our interval is 2, and the other end of our interval will be 2 plus h, where h can represent any number. We can add 2 plus 1, 2 plus 3, 2 plus 4. We're not sure what the number is. We're just going to use 2 plus h as a placeholder for whatever value of h we would use in the future. So we first need to figure out what is f of x when x equals 2. So we'll substitute 2 into our equation, and this will be our point P. We have 2 cubed minus 2 plus 20, which is 8 minus 2 plus 20, so 26. The second end of our interval, which we will call Q, is when x is 2 plus h. So again, we'll substitute 2 plus h into our equation. Using FOIL, we know that this is equal to 8 plus 6h squared plus 12h plus h cubed minus 2 minus h plus 1. So when we find our average rate of change, we can combine a few like terms here. So the 8 minus the 2 plus the 20 gives us 26. And the 12h minus the h gives us 11h. So f of 2 plus h comes down to 6h squared plus 11h plus h cubed plus 26. And we want to subtract f of 2. And f of 2 we know is 26. So we'll subtract 26. And then down at the bottom we have 2 plus h minus 2. The 2's will cancel and we'll just have h down at the bottom. So we can simplify this a little bit more, and we'll have 6h squared plus 11h plus h cubed. The 26's will cancel out, and we'll just have h. Let's take it one step further. Every term in our numerator has an h, so let's divide everything by h, and we'll get 6h plus 11 plus h squared. So that is our average rate of change. We're not quite done yet because we still want to find our instantaneous rate of change. So our instantaneous rate of change, we need to find the limit as delta x approaches 0. So the limit as delta x approaches 0 of delta y over delta x, if we look back at our average rate of change, while simplifying, we notice that delta x is the same thing as h. So delta x is equal to h. So we want to know the limit as h approaches 0 of delta y over delta x. So that is the same thing as finding the limit as h approaches 0 of our average rate of change, which we know is 6h plus 11 plus h squared. At this point, we can directly substitute the 0, and we are looking for 6 times 0 plus 11 plus 0 squared, which is equal to 11. Therefore, our instantaneous rate of change is equal to 11 at the point x equaling 2. Page 2 leads us right into page 3, where now we're looking for the slope of a curve. So the slope of a curve at a point P, a comma f of a, is the slope of the tangent line to the curve through the point P. So again, remember the tangent line is the line that intersects only one point. So the slope of our tangent line is going to be the limit as h approaches 0 of f of a plus h minus f of a all over h. So this should look very similar to page 2, where we had the limit as delta x approaches 0 of delta y over delta x. Remember that at the end of our problem in page 2, we realized that delta x is actually equal to h, and that is true for the tangent line at any curve. So we want to find the slope of the curve f of x equals 1 over x at x equaling a. So this is going to be a purely variable problem because we don't actually have a number for a. So we're going to work through it similarly to the problem on page 2, but now we're just going to use the variables x and a and h. So when we substitute a into our function, we get 1 over a. We can't simplify anymore. When we substitute a plus h into our function, we get 1 over a plus h. Again, we cannot simplify any further. So, reminder that our first step is to find the average rate of change. So we want to find basically the slope on the interval a to a plus h. So again, we'll do delta y over delta x. So 1 over a plus h minus 1 over a, all over a plus h minus a. So in order to do this problem, we are going to need to find a common denominator for our numerators. So we're going to multiply this part by a and this part by a plus h so that we have a common denominator in our numerator. So that gives us a over a times a plus h for one end minus a plus h over a times a plus h. And then down at the bottom, we have the two a's will cancel out and we'll just have h. So the numerator will simplify out to being a minus h over a squared plus ah all over h. Which then simplifies to being negative h over a squared plus ah all over h, which finally simplifies to being 1 over a squared plus ah. So this is equal to our delta y over delta x, which was the slope of our secant line. And now we want to find the limit of delta y over delta x as h approaches 0. So we want the limit h approaches 0 of 1 over a squared plus ah. So when we directly substitute, our h will turn into 0 and we'll be just left with 1 over a squared. And that is our instantaneous rate of change. So the slope of our tangent line. Second question asks us, where does the slope equal negative 1 over 4? My apologies really quickly. This should be a negative 1. So we want to know, where does the slope equal negative 1 over 4? So we have negative 1 over a squared, and we want that to equal negative 1 over 4. So basically we're looking for, when does a squared equal 4? We know that happens when a is equal to plus or minus 2. For the bottom half, we're just looking for an estimation of the slope of the curve at the point xy. So we want an estimation of this line at the point xy. So we just want an estimation of the slope. So all we're going to do is go back to algebra 1 and take the slope of the line graphically. So find 2 points on the line and then find the change in y over the change in x. So our change in y is 4 and our change in x is 2. So our slope is equal to 4 over 2, which is 2. And we'll do the same thing for the second graph. Find 2 points. And find our change in y, which is 6, and our change in x, which is 5. So change in y over change in x is 6 over 5, but our line is decreasing, so our slope will be negative. Okay, so now that we talked about the tangent line, the secant line, and our instantaneous and average rates of change, we're going to look for the tangent line and the normal to a curve. So we'll talk about what that means in a second. So example number 1 wants us to find an equation for the line tangent to the curve f of x equals 4 minus x squared at x equaling 1. So we want to find the point of tangency. So given that x is equal to 1, we want to find our y. So we are going to substitute 1 into our function and find f of 1. So we have 4 minus 1 squared, which is equal to 3. So our point of tangency is 1, 3. That is really important when we start to write the equation. Next, we want to find the slope of the tangent to the curve at x equals 1. So remember, in order to find the slope of the tangent, we need to first find the slope of the secant. So we need the change in y over the change in x. We're only given a point, so we need to create our intervals. So we'll start at 1, and we'll go to some value 1 plus h. So if we make a table, x and f of x, we know that we're going to start at 1, and we're going to go to 1 plus h. So when x equals 1, we know that f of x is equal to 3. And when x equals 1 plus h, we can substitute that into our function, and we'll have 4 minus 1 plus h squared, which can be simplified to 4 minus h squared plus 2h plus 1. So now, to find the change in y over the change in x, we will have 4 minus h squared minus 2h minus 1 minus our f of 1, which was 3, all over 1 plus h minus 1. And this will lead us to having negative h squared minus 2h over h. Now that is the slope of our secant. So to find the slope of our tangent, we need to take the limit as h approaches 0 of negative h squared minus 2h all over h. So we can simplify this a little bit by dividing everything by h, since there's an h term in every piece of the numerator. So we'll have negative h minus 2, and when h equals 0, we'll just have negative 2. So there is the slope of our tangent line. Now to write the equation of the tangent line, we again go back to Algebra 1 using our point slope form of y minus y1 equals m parentheses x minus x1. We're going to substitute our point and our slope to write our equation. So we have y minus our y1, which is 3, equals our slope, which is negative 2, parentheses x minus our x1, which is 1. And there is the equation of our tangent line to f of x at x equaling 1. The normal line to a curve at a point is the line that is perpendicular to the tangent line. So we have to remember that the tangent is perpendicular to the normal. And to find the slope of a perpendicular line, knowing that our tangent line slope is negative 2, the perpendicular slope will be the reciprocal with the opposite sign. So if we flip negative 2, we get 1 half, excuse me. And then negative 2 is negative, so 1 half will be positive. So our slope to the normal curve will be positive 1 half. To write the equation, everything stays the same except for our slope. So we'll have now y minus 3 equals 1 half x minus 1. And that would be the equation to the normal line of the curve. Okay, so now rates from a table. This process should look very similar to when you were finding the slope on a table in Algebra 1. So the data in the table gives coordinates s of a moving body for various values of t. Number 1, we want to find the average velocity of the body during the first 3 seconds. So to find average velocity, the average velocity is our average rate of change. Okay, so this is the slope at 2 points in our table. So the first being s of 3 and the second being s of 0. Because in the first 3 seconds, we're looking at the interval from 0 to 3. So s of 3, we know is 48.5, and s of 0 is 12.5. And then 3 minus 0 is 3. So if we continue on, this becomes 36.0 over 3, which is equal to 12. And since we're doing s over t, the units for s were feet, and the units for t were seconds. So our average velocity during the first 3 seconds is 12 feet per second. Now we want to find the average velocity of the body for t equals 2 and t equals 4. So now our interval is from 2 to 4, and we're going to do the same thing that we did for the top. We want to know what change of s is over change of t. So you should do this problem on your own, and we're going to look at number 3. We want to estimate the velocity when t equals 1. So now they're giving us just one value of x, one number instead of an interval. So on a table, right, we know what t equals 1 is, but we want to know the estimated velocity. So we're going to look at the value right before and the value right after to help us find the rate of change. So we are going to look at V of 1 approximately being S of 1.5 minus S of 0.5 over 1.5 minus 0.5. So S of 1.5 is 44.0. S of 0.5 is 26.0. And 1.5 minus 0.5 is 1. So if we evaluate this, we get 18 over 1, which is 18. And don't forget your units. We're still doing feet per second. So at t equals 1, the estimated velocity is 18 feet per second. So using that same logic, now try to figure out the estimated velocity of t equaling 4. Here's a hint. Since you do not have any number greater than 4 on your table, you can use 3.5 and 4 to help you estimate. So your interval here would be 3.5 to 4 to help you estimate. So to find the rate from a graph, again, very similar to finding the slope of a graph. So the graph below shows how the price of a certain stock varied over a recent trading day. We have money or price over time. So we want to find the average rate of change of the price of the stock from 8 to 1. So if we look at our graph, when time is 8, we're here. When time is 1, we're here. It looks like our Y values are going up about 50 cents for each tick mark. So we can say that on our interval 8 to 1, we can say that at time 8, our price is $5.5 or $5.50. And at time 1, our price is $6.50. So using that information, we want the average rate of change. So we want the change in price over the change in time. So we're going to have the price at time 1, because that is our furthest out. The price at time 1, which is $6.50, minus the price at time 8, which is $5.50, all over the amount of time that has elapsed. So from 8 o'clock to 1 o'clock, only 5 hours have passed. So when we simplify this, we have $1 over 5 hours, which is equal to 0.20 cents per hour. So similarly to tables, to estimate the instantaneous rate of change, we would look at the time 9:15, which is about here, and we would draw a line. So to find the stock at 9:15, we don't actually know what that number is. We don't know what the rate of change is. So we will look at a time right before and a time right after. So our interval will be 9 o'clock to 9:30. So at 9:30, our cost seems to be $4.50. So we have $4.50 minus, at 9 o'clock, our cost seems to be $6.50. And the amount of time that has elapsed from 9 to 9:30 is half an hour. So when we evaluate this, we get -2 over 1/2, which is equal to -$4 per hour. That concludes the notes for 2.4. Be prepared to come into class tomorrow with whatever questions you might have and to work on the problem set.